In this video, we're going to look at translating functions, look at vertical shifts, horizontal shifts, and things like that. So in number one, they're asking, or they're telling us to make a table of values for the following equation and then graph that equation. So here we have y equals the absolute value of x plus 2, and this plus 2 is basically what's going to cause our shift. Now, we'll get into the formula a bit later, but that plus 2 being outside the absolute value means that this is going to be a shift up 2 units. Right? So your normal parent function, your normal y equals absolute value of x is going to be shifted up 2 places because of that plus 2. So to make a table, you're going to make an xy table, and we'll come up with 5 numbers. Now, since there's nothing being done to the x on the inside, you can use your standard numbers, and I would usually recommend -1, -2, -1, 0, 1, and 2, and then plugging those in and finding out what your y values would be. So if I plug in -2 into the absolute value, I would get 2, 2 plus 2 would be 4, and then I just fill out the rest of this. So 0 plus 2 would be 2, 1 plus 2 would be 3, and 2 plus 2 would be 4. Again, these numbers here are being plugged in as my x value to get a result of y. Now these give me coordinate pairs. I'm going to rewrite them, but you don't normally have to do this. These 5 coordinate points will be enough to give me the shape of my graph. So I have -2, 4, which is going to be here, -1, 3, which will be there, 0, 2, 1, 3. Notice how we start to change directions there, and 2, 4. So this 0, 2 winds up being my vertex. And again, later on, we're going to get into a little more detail with that. But what's going on here is we want to connect these dots. Since it's an absolute value function, it should look like a V. The drawing's not perfect there, but you get the idea. Let me fix that line. And we'll have something that looks like this. Make sure you put your arrows so that we know the graph goes forever in both directions. But that's it. All right, we made the table. We made the table and we graphed the equations. That's all we're looking to do. Now in number 2, they tell us to make a table of values again for the following equation and graph the equation. So we're doing the same thing. However, this time that 4, the number that's causing the shift, is on the inside. That's going to tell us that there's going to be a shift. And this is where we have to be careful. Left 4 places. All right, so we're still trying to create our XY chart, and then we'll fill out, get our coordinate points. Now, if we go back to number 1, that number on the outside was very specific. All right, it said plus 2. We followed exactly as it would appear. That plus 2 meant that our vertex from our parent function shifted up 2 places. All right, but what's going to happen this time, although the plus 2 seems straightforward moving up, when it's inside of the absolute value, it's going to be the opposite of what you would think. So plus 4, you're usually thinking moving to the right along the graph. It's actually going to tell you to go left. So when we plug in these numbers, our standard numbers of -2, -1, 0, 1, 2, we don't want to use those standards because what's going to happen is you're not going to get the vertex. The vertex, this 0 is going to be shifted left 4 places. So we want to subtract 4 from that, and that's going to tell us where our new vertex would lie. So instead of using -2, -1, 0, 1, and 2, I want to shift those numbers 4 units. So we're going to shift them 4 units left, and we're going to do that by subtracting 4 from each one of them. It doesn't always make sense right away, but once you get into practice with this, you'll see that it does wind up making sense. And once we graph this, you'll see why. So these new numbers are going to become -6, -5, -4, -3, -2. And these are the numbers I'm going to use as my x values. So if I plug in -6, these values in as my x, Negative 6 plus 4 is negative 2, and the absolute value would be 2. Negative 5 plus 4 would be negative 1, so absolute value is 1, and we would get 0. Negative 3 plus 4 is 1, absolute value is 1, and negative 2 plus 4 is 2, absolute value 2. So my coordinate points are negative 6, 2, negative 5, 1, negative 4, 0, negative 3, 1, and negative 2, 2. Now if I graph those, I have negative 6, so over to 2, negative 5, 1, negative 4, 0, and now notice negative 3, 1 is going to start going back up, and then negative 2, 2. So we'll connect these dots. Again, not the most perfect sketch, but you get the idea. And what you want to notice is this vertex, right? So that vertex shifted from the origin 4 places, which is what we said would happen. We said it was going to shift left 4 places. If you had used the standard negative 2, negative 1, 0, 1, 2 as your x values, you would have wound up with only part of the graph, all right? You only would have actually drawn this part here, so you never would have known where the vertex was. So it's important when there are shifts left and right, you're going to have to adjust your x values. All right, x is being changed because your graph is being shifted horizontally. So anytime the graph is shifted horizontally, again, you need to make sure that your x values in your chart are adjusted as so. So going left, you're going to subtract those 4. Had we been going right, we would have added to our x values. Again, once you get some more practice with this, you'll start to see it a bit more, or you'll start to understand it and get used to it pretty easily.